What's going on, you guys? So we're going to do Grasshopper Summation. So we're going to write a program that finds the summation of every number from 1 to m, or 1 to num. The number will always be a positive integer greater than 0. So for example, summation 2, so we do 1 to 2, okay. The number will always be positive integer greater than 0 from 1 to num2. It looks like we're including num. So 1, 2, 3, 4, 5, okay. Cool. So let's try and do an example, and let's see how we can make this happen. Okay. So let's go like this. Let's go like that. Okay. So we have 8. So we need to return 36. So how are we going to do this? So I'm thinking we're going to have a total, and we're going to have a bunch of values. We'll say we could say values to sum. Maybe we have an array and it has all the values we're going to sum. So which values are we going to sum? Everything from go that. And let's go like this. Search for digit. How can I do this simply? We're going to do a regex real quick. Hopefully it works. Okay, so we're going to replace this with 1, comma. Okay, it worked. Nice. All right, so these are the values to sum. So we make this. We'll make this values to sum array, and we can go over our index. Starting at 1, the first one we want to sum, and we'll add it to our running total. So let's see. So okay, and we can add the indexes too. Okay, 0, 1, 2, 3, 4, 5, 6, 7. Okay. So we'll loop over our array, and we'll add to our total, and then we'll return a total at the end. So let's see if this is going to return 36. Okay, so we start, add 1. Whoops. Okay, now we're going to add 2. So that's 3. Add 3. So we're at 6. Add 4. So we're 10. Add 5. So 15. Add 6. So 21. There we go. Add 7. 28. Add 8. So 36. Is that right? Uh-oh, wait. Yeah, that's right. Plus 2 is 30, plus 6, 36. Okay. All right, so it looks like that works. Let's try and write that in pseudocode, and we'll convert that to Python. So function summation. It's going to take an n, which is going to be an integer, and we're going to return. Whoa, what is that? We're going to return an integer. Okay, so what are we going to do? So we're going to have a total, and then we're going to, we're going to have a values to sum. So I guess we'll say values to sum is get values to sum. Should I do this? I'm thinking of, should I write another function to get these values to sum? Maybe. We'll do it without that, and then maybe refactor it afterwards. So we're going to do values to sum. Values to sum. Start it as an empty array, and what are we going to do? We're going to loop, iterate from 1 to n for each. Append, iterate, we'll iterate, let's call it index. Append index to values to sum. So now we have, after we do that, we're going to get something like this. Okay, so we have our values to sum, and now we need to get the total of adding them all together. So how are we going to do that? We're going to loop over. We're going to start at the first. We could start at the end if you wanted to, but we're going to start at the first element, and we're just going to add these to our running total. So what are we going to do? We're going to iterate over values in values to sum. and say total equals total plus each value. Okay, and then we're going to return our total. Okay, so now we want to think about, do we want to refactor this and say, and define this as a function? I would say, I mean, you would want to refactor if it was tough to understand. Like maybe it doesn't take only three lines to build this array. Maybe it takes 50 lines. In that case, you might want to make it a function. But because it's so small, we're gonna skip the refactoring. Okay, so let's translate this to Python. Summation, it's gonna take an n, which is an integer, and we're gonna return that running total. So that'll be an integer. Okay, so we're gonna build values to sum. Start off empty array, and how are we gonna loop over 1 to n? We'll say, val to sum, VTS, val to sum in range from 1 to n plus 1. So we learned previously that the end is an exclusive value. So if we do n plus 1, the last VTS, the last value it will equal is n. So that's why we do n plus 1 here. Yes, that's right. Okay. And so what are we going to do with each VTS, or value to sum? We're going to append it to our list. VTS. Okay. And now let's set our total equal to 0. So now we're going to iterate over each value to sum in our list and add that to total. So let's see. So we can do this two ways. We could do for VTS and values to sum, or we could do for index and range len values to sum. Either of these are okay. This one's less code, so it's a little bit easier to read. So I'm going to do this one. But sometimes you want to do the other one. It's good to have both tools in your tool belt. Okay, so we're going to say total equals total plus VTS. And then we're going to return total at the end. Okay, so let's run through our example to make sure that it's working as we think it would. So we're going to keep track of two things. We're going to keep track of, so values to sum starts at empty. Whoops, so we got to build values to sum. Okay. And then we're going to work on our total. Okay, so let's work through this. All right, so values to sum is empty. So for VTS, and we'll keep track of what is VTS. VTS, it starts at 1. So we know it starts at 1, and it's going to go up to 8. We're doing 8 here. Okay, so VTS is 1, and we're going to append VTS and then increment VTS. So we're going to append 1, now increment, and append 2, and increment. We're going to keep going until we get to 8. Okay, so find 2, increment 3. We're going to continue appending VTS. 4, increment, find 4, increment, find this guy, increment, keep going, 7, one more, find 7. Okay, so now we've built values to sum, and here are the indexes. The first index, it's 0-based indexing, so the first one is 0. Okay, so now we have total equals 0, and for VTS and values to sum, let's just call this V for shorthand. Okay, so, oops, just gonna call this V. We're gonna loop over each V in our values to sum and add it to total. Okay, so V is 1, so we add 1. Now V is 2, so we add 2. V is 3, we add 3. is 4. We add 4. 5. Add 5. 6. 6. Whoops. There we go. 7. We add 7. Then we add 8 finally. 36. Okay, so it looks like it's working. Now let's double check to make sure that we didn't have any syntax errors. All right. All right, let's see what we get. Okay, so we did it. So if you want to, you can take a look at the solutions, but no need to if you don't want to. Save the solutions for when you're stuck. 30 to 45 minutes. You work on this and then cut it and look at the solutions. That's the game plan. Okay, so we're looking for now we're gonna skip the one-line solutions and see if we can find something that. Okay, here we go. Here's another way to do it. Okay. So they skipped a step. So we built a values to sum array. They just went directly to adding to total. So that's okay too. And so this is actually good. It's good to learn from this. This is better because it uses less space. So when we build values to sum, that takes up space in memory. And so it's a more costly operation when we use space. So that would take on the order of n units of memory to build values to sum. This one skips that. So this is actually a better solution. It takes the same amount of time, but it uses less space. So it's actually good that we checked out this solution. So now let's try and implement, let's take what we've learned here and try and implement that where we're saving space. This is a different solution, saving space. Okay, let's try and, so look at that and try and remember what happened. And then we're gonna try and implement that so that we've now learned a new trick to save space for future problems. So let's see. So let's say total equals 0, and our goal is to do this without using extra space. So we'll say for I in range len nums, and when we do this, we don't necessarily have to start at 0 or at 1. We could. This and this will both be the same answer because we would just be adding 0 to total, which doesn't equal anything. So we can go like this and then return our total. Okay, so let's check that that works. Oh, okay. Let's see what happened. What's the error? Name nums is not defined. Oh, okay. Let's try it again. Oh, I have another nums. Whoops. This one's going to fail too. We know this one will fail because we have, yeah, so this should work. No. Wait, what? Oh, this is not a, oh, made another mistake here. So this is why type annotations are helpful. I thought that this was a list. Yeah, so that wasn't clear in my head. So now when I add these type annotations, I know, okay, it doesn't make sense to take the length of 5 or the length of 4. So that's why type annotations are nice. So this should work. Well, we're doing this now. Okay. Yeah, so what was the issue there? I thought that num was like list of num, but that's not what it was. Okay. So let's see if this works. Oh. Ah, we're missing the last element. Okay, so when you give one value, it's exclusive. So this would take on, I would take on 0 up to num minus 1. So we're missing the last value. So we do +1 here. All right. There we go, guys. Okay. All right, there you go. So we've learned a new trick. We can avoid using memory by, well, let's call it the avoid using memory trick. All right, guys, stay tuned for the next one.